Example 5 is the start of using a technique called interpolation. So sometimes when you have a frequency table that is grouped, you can work out an estimate for things like the upper quartile, lower quartile and the median, and also any percentiles. So this is a really tricky example where we're going to introduce percentiles. We're also going to look back at bounds used in S1. So to take you through this, we can look at this paragraph here, which says when data are presented in a group frequency table, you can use a technique called interpolation in order to estimate these things. Interpolation basically assumes that the data values are evenly distributed within each class. So it's kind of spread out evenly between the class intervals. So these two bits of data, they are spread evenly between the class intervals. Same for these 25, the 30 and the 13 bits of data. Okay, so example 5 talks about the length of time to the nearest minute. Okay, should ring alarm bells that we need to do a little bit extra. But it's the length of time to the nearest minute spent on the internet each evening by a group of students. Okay, so that's what this information represents. We want to find an estimate for the upper quartile. So we need to use the definition that we've just used in example 4. We need to see how many bits of data there are, and if you add all these up, there are 70 bits of data. To find the upper quartile, we need to find 3/4 of 70. And 3/4 of 70, if you work that out, it actually means that we're going to find the 52.5 bit of data. Okay, so what we're going to do is we are going to use interpolation to do that. The way I'm going to try and explain it to you is by thinking about the boundaries of the class and how far into the class interval it is. So first of all, we need to find the 52.5 bit of data. So we're going to look in the table and we're going to see where it lies. So we've got the first 2 bits of data there. Then we've got the next 25 bits of data there, so altogether we've had 27 bits of data. And then by the time we get to here, then we've had 57 bits of data altogether, meaning that our upper quartile is going to lie in this category here. So, at the start of the category, there were 27 bits of data. So here, there were 27 bits of data. Here, there were 57 bits of data. So that's where the 27 and the 57 come from. Okay, let's move it up slightly so we can see it all. Okay, and then what we need to look at is we need to consider where the bit of data we're trying to find is. So we want the 52.5 bit of data, the 52.5 bit of data. So the way I'm going to think about it is, what fraction of the way into this class interval is our 52.5 bit of data? Well, to work that out, we need to consider the total size of the class interval, which is 30, because there are 30 bits of data in there. And then what fraction of the way in? Well, it's not gone all the way in, so it's not 30 out of 30. It's not halfway in. It's actually only 25.5 of the way in. Okay, now the way I've worked that out is by doing 52.5 take away 27. So I know that the fraction of the way in that the 52.5 bit of data is this fraction here. So what I want to know is, well, actually, where would that lie in terms of the length of time spent on the internet? Because it needs to lie the same fraction of the way in to the data. So To do that, I need to think about, it is this class interval, okay, but actually it's not going to start at 34. And the reason it's not going to start at 34 is because of this here. All of these times are to the nearest minute. Therefore, this one here won't be 34, it will be 33.5, the lower bound. And this one here won't be 36, it will actually be 36.5. So we're going to put that there. Now we need this bit of data, which is this fraction of the way in. Okay, so whole class width is 3, and we do not know this bit of data, but we know it has to be the same fraction as this. Therefore, we're going to work out what that would be. So we need to know this this distance here, or this distance into the class interval here, as a fraction of the whole class width here. So the whole class width is 3. We need to know what distance this is, but it needs to give the same fraction as this one. Okay, so if we rearrange that and we work out what the question mark or the missing value is, that will give us 36.05. So if we multiply it by 3 and then add on 33.5, that will give us 36.05 as an estimate of our upper quartile. Okay, let's just move it up so we've got it all on there. So then for part B, we need to look at an estimate for the 10th percentile. So this is our first little introduction to percentiles and how they work, and we're looking for the 10th percentile. So for part B, we have 70 bits of data and we want to work out the 10th percentile. Well, that means we need to work out 10% of 70, which is 7, and therefore we need to work out the 7th bit of data. Okay, so we need to work out the 7th bit of data for our table here. Okay, we're going to set it up in a similar way. So we're going to see if we can find where the 7th bit of data is. Well, there's 2 bits of data there. Then we've got the next 25, so we've got from the 2nd to the 27th bit of data. Okay, so I'm going to draw a similar scale to what I drew last time. And we've got 2 there, and we've got 27 there. We're looking to find the 7th bit of data. We've got the first 2 bits of data there, the next 25 there, which means we're looking in between 2 and 27. We want to find the 7th bit of data, which is here. So I kind of want to know what fraction of the way into this interval it is, and I would do that by doing 7 minus 2, which is 5, so it's 5 in, out of the whole width here, which is 25. And we're going to leave that as 5 over 25, but we could simplify that down to 1/5 if we wanted to. Okay, and then what we're going to do is, again, we're going to look at the bounds. We know it lies in here, therefore the lower class interval isn't going to be 32, it's going to be 31.5. And then the upper is going to be 33.5. Okay, this is the bit of data we're looking for, which is going to give us the estimate for the 10th percentile, and we know it needs to be the same fraction of the way in. Okay, so therefore we know the whole class interval is going to be 2. and we want to know the distance between here, which will give us the same fraction here as we have here. So therefore we're trying to work out that value, and to do it we'd need to find this distance. We would do this value, take away that one. We need to rearrange this in order to work out what the question mark is. So we'd multiply it by 2 and we'd add 31.5, and that would give us a value of 31.9. That would be an estimate for the 10th percentile. Okay. Now I imagine some of you may be a little bit confused about why we're using the 25.5th bit of data here and the 7th bit of data here, even though the rules from the last one told us that actually we'd need to round this up and use the 53rd, and this one we'd have to use between the 7th and the 8th. So it's something that we do just need to look at, which I'm sure you've already read, but if you haven't, for grouped continuous data, or data presented in a cumulative frequency table, to work out Q1, we just divide it by 4 and we use that bit of data. For the median, we divide it by 2 and use that bit of data, and for 3/4, we do 3/4 of it and we use that data value. So there's none of those rules that we have for discrete, which is the previous example. We have these rules, which is for grouped continuous data. And that is the same for percentiles, which kind of gives us a reason why when we wanted the 10th percentile, we just use 7, not halfway between 7 and 8. And for this one, why we use the 52.5th bit of data, not the 53rd bit of data. So I'm hoping that the idea of this scale helps with the understanding, and I wish you the best of luck